Okay, so solve simultaneous equations via elimination and substitution to find points of intersection. Brilliant. Alright, so we're going to go back a little bit just to make sure that we're okay first. So we've got two linear functions here, y equals 2x minus 4, y equals 4x minus 10. So I want to sketch these things. Great. Well, for free, I'm getting a y-intercept there, minus 4. And make this one blue. Cool, okay, so I'm starting at minus 4, my gradient's 2, so cross 1, up 2, cross 1, up 2, cross 1, up 2, cross 1, up 2, so on, so on, so on, so on, so on. Eventually, I get a line. Great. So that's blue point. Alright, similar story, we'll do the red line. Cool, y-intercept negative 10, way down here. Gradient 4, so cross 1, 4, whoops, we're doing this in red. Cross 1, up 4, cross 1, up 4, cross 1, up 4, cross 1, up 4, which is I think. Yep. Cross 1, up 4, 6, 10, whoops, 10. That's better. Cool, and so we get something like that. You make it a bit better with the ruler and everything, obviously I'm doing that a bit freehand. Great. What we're interested in today, we're trying to figure out where these things intersect, which just visually, well, that must be there at some point. And if you draw this nice and carefully, maybe on grid paper, ruler, make everything nice and straight, you will hopefully end up with 3, 2. Yep. So we can chuck that in just to make sure. That's 3, that's 2. Okay, 2 times 3 is 6, minus 4 is 2. 4 times 3 is 12, minus 10 is also 2, so they both exist at the point 3, 2. Fantastic, okay. Well, we had to do a lot of work for that. This ended up as a nice point. If there was any fractions or anything in this, very easily these numbers could be terrible, and then if you're doing it on grid paper, it's going to be really hard to read. So it would be nice if we had a smarter way of doing this. Alright, so let's start with the same two functions. Move this across slightly, set that space to right. Y equals 2x minus 4, y equals 4x minus 10. Okay. First thing I'm going to do, I'm going to call one equation 1, call the other equation 2. Call them A and B, you can call them anything you want, smiley face, or any face, doesn't matter, it's just a name. Cool, alright. Well, I've got two functions with two variables. Alright, what I would like to do is get rid of either x or y. And just work with one at a time, make it simpler, make life easier. Well, just like when you have an equation you can add 5 to both sides, or you can divide both sides by 2, or whatever else have you, you can also play with two equations at the same time. So, what I'm going to do is go equation 1 minus equation 2. Okay, well, what does that do? Well, I've got equation 2 starts with y, equation 1 starts with y. Y minus y, that's 0. Okay, 4x minus 2x, that's 2x. Negative 10 minus negative 4 would end up being negative 6. Cool, so just to run through again, this minus that gives me 0, this minus that gives me that, this minus that gives me that. Fantastic. And if we look at what we've ended up with, we've got an equation with just a single x in there. Brilliant, this is old, we know how to do this. So if we solve it, move 6 across, divide by 2, brilliant. Turns out x should be 3, isn't that lovely? Okay, well we've got x. Well, we really need y as well. So what we're going to do is substitute in this into either of them. Doesn't matter which one, you're free to choose. I'm going to choose the top one because the numbers are smaller, makes life easier. Always make life easy for yourself wherever you can. Cool, so we've got y equals 2, lots of x, which we now know is 3, minus 4. Brilliant. Well, that's that. So y is 2, fantastic. Put a little box around it so that we know what our end result was. Great. So we've got x is 3, y is 2, which, unsurprisingly, that's what we had before. Beautiful. Well, let's imagine for a second that we had this. So, okay, let's imagine for a second we didn't have this, rather. Let's figure out how to solve this. Check that this is correct. So we're replacing all x's with 3s, all y's with 2s. we've got 2 there, 3 there, 2 there, 3 there. Cool, alright, 2 by 3, 6, minus 4 is 2, that checks out. 4 by 3, 12, minus 10 is 2, also checks out. Beautiful, so we're happy with that's right. So that method was elimination, because we eliminated the y's. Alright, well, what about this newfangled substitution method? What we're going to do with substitution is say a very plain and obvious statement, y is equal to y. That seems really daft, but over here we've got y equals some stuff and y equals some stuff. So if I think of this as the first y, this side is saying 2x minus 4, the other side is saying 4x minus 10. And again, we've just got one equation with just one of the variables in there, so we're good to go. Alright, I've got x's on both sides. We know how to do that from before. Just kill off one of the x's, or minus 2x from both sides. Cool. Add 10 to both sides. Cool, divide by 2. Brilliant. 1 down. And from here. Cool, we've got 1. Great, we can sub it into either of the original equations. I could sub it into 1 just like before, but just for giggles, I'll sub it into 2 for this one. Cool, so we've got y equals 4 lots of x, which is 3, minus 10, y equals 12 minus 10, y equal 2. Beautiful, we're done. And we already know from before that that's right. Fantastic. Alright, well, let's just slowly fiddle around with this. Now I've got this pair. Well, that's not in the y equals mx plus c sort of stuff, but they are still straight lines, so we can still work with it. First thing, give them names, just so you can talk about them. What do we notice? Well, we notice that, oh cool, there's a 2x here and a 2x here. Okay, well, what if I take one equation and minus the other one so that those two x's kill each other? Brilliant, should I do 1 minus 2 or 2 minus 1? Well, everything's bigger in 2, so I'll do 2 minus the 1, just so that I don't end up with negatives. You can do 1 minus 2, but make life easy for yourself where you can. Cool. So equation 2 minus equation 1. This minus that, nada. This minus that, 2y. 2y. This minus this, 10. Beautiful. Divide by 2. So we've got y is 5. Beautiful. Alright, we've got 1. Sub it back into one of them. I could pick 1 or 2. One's looking like smaller numbers, so I'll use that today. 2x plus 3 lots of 5 equals 23. So it's dying a little bit. Alright. So 2x plus 15 equals 23. 2x equals what? 8. X equals 4. Beautiful. Cool. We don't know if this is right, so we should check. X's are 4s, Y's are 5s. Okay? 2 by 4, 8, plus 3 by 5, 15, 8 and 15, 23. Yep. 2 by 4, 8, 5 by 5, 25. 8 plus 25, 33. Yep, checks out. We're all happy. Right. Alternately, we could do substitution. You will always be able to, you're always free to choose. However, one's usually faster than the other, but which one totally depends on the scenario. So here's what I'm going to do. I'm going to rearrange this slightly. I've got two x's, and they're both the same, so I'd like to keep those the same. Well, what if I go 2x equals, and then move the 3y across? What if I do that? Beautiful. Okay, which way we got this? Not that. Cool. So I'm going to rearrange one of them. Beautiful. Well, I can say, rather obviously, 2x has to equal 2x. Okie dokie. Well, my first 2x equals this. Sorry, no, that's not what I'm doing. Ooh, forget that. Yeah, no, that is what I'm doing. Oops, sorry. Cool. So 2x has to equal 2x, great. This 2x is going to equal all of this stuff. Alright? My other 2x is going to be here. Well, that means when I write this equation, 2x plus 5y equals 33, I could replace this 2x with what 2x actually equals. So I could replace it with 23 minus 3y. Beautiful. Okay, well, I've got a whole lot of stuff going on here. 23 minus 3y plus 5y, and that's plus 2y, equals 33. Great, I've got an equation with only one variable, so I can solve that. Old school stuff now, y equals 5. Cool, this is solution, partial. Great, we've got one, need the other, so I sub it in again. This time I'll pick 2 just because. So we've got 2x plus 5 lots of y, which is 5, equals 33. Plus 25 equals 33. Brilliant. Minus off 25 gives me 8. X equals 4 equals 4. That's that. Beautiful. And we don't have to check it again because we already checked it on the last one. Where did I put those? Oh, there. Okay. Back up low. Looking good. Okay. So, another new one. We take a look at it and go, okay, what's in common? Well, these are no good to me, but I've got 4 y's twice. One's negative, one's positive though. Well, here's equation 1, here's equation 2, as always. Well, before I was minusing them because they were the same. Well, if I add these, they'll kill each other. Brilliant, all right? So I'll go equation 1 plus equation 2. 3x plus 5x, 3x plus 2x is 5x. Negative 4y plus 4y, they'll kill each other. Negative 5 plus 10 gives me 5. Brilliant. Now we're just solving as normal. Here, and then sub in. In this case, I'm going to pick equation 2. You could pick equation 1, there's more negatives, so I'm just avoiding that. 2 lots of x, which is 1. Plus 4y equals 10, 2 plus 4y equals 10, 4y equals 8, y equals 2. Is that what we had before? That's not what we had before. Oh no, it's a different one. Yep, that's fine. Cool, we don't know if that's correct or not, so we should check it. 1, 2, 1, 2. Alright, 3 times 1 minus 4 times 2. So 3 minus 8 is negative 5. Yep. 2 plus 8 is 10. Yep, that all checks out. Next guy. Well, now I've got this. Oh dear. I've got x's on the left, and then a constant and the y on the right. This one I've got an x and a constant on the left, and then a y on the right. So they're not balanced in the same way. Well, first thing, call one 1, call the other 2. Well, what can I do here? Well, I can notice that, this guy and this guy are the same. And I know 3y has to equal 3y. So, I'm going to write this part equals 11y minus 3 lots of, minus this 3y. And this 3y is equal to 7x minus 1. Beautiful. An equation with just one variable, we know how to solve that. So, expand out first. Get rid of him. There you go. Cool, so we've got 11 minus 7x, negative 1, plus 1. Gives me 12 minus 7. Add 7x to both sides, 12x equals 12. Gives me x is 1. Fantastic. Fantastic. Okay. Cool, we've got x, still need y, so sub in to either of them. I am inclined to use this one. You could use either though. Cool, so we've got 7 lots of x, which is 1, minus 1 equals 3 lots of y, 7 minus 1, 6, divided by 3. Cool, great, we don't know if that's right, we should always check. X's are 1s, y's are 2s. 5 on the left, 11 minus 3 lots of 2, 11 minus 6 is 5, yep. 7 minus 1, 6, 3 lots of 2, 6, yep, all works. Fantastic. Cool. Throwing more troubles at you. Okay, equation 1, equation 2. What do we notice? Well, the x's don't match, the y's don't match. Crap. Well, what could we do? Well, I could turn this 2 into a 4 by multiplying everything by 2. So let's do that. Equation 1, multiply it by 2. Alright, well that would become 4x plus 6y equals 16. Now to avoid confusion with our naming, I'm going to call this 1 star. So it's kind of equation 1, but I've fiddled with it, so I'll put a star on it just to say, yeah, it's kind of the same thing. Well, it is the same thing, but anyway. Great. Well, what can I do now? Oh, sweet. The 4x's both match up. I want to minus these, so I'll go equation 1 star minus equation 2. 4x minus 4x, dead. 6y minus 5y is equal y. 16 minus 14, 2. Sweet. We didn't even have to do any more work. We got that one for free. We've got y, so we still need x. Sub into either of them, smaller numbers, I'll pick that. Could pick equation 2, doesn't matter, but that's what I feel like doing. Making life easy for myself. 2 equals 8. Brilliant. 2, x equals 1. Alright, getting pretty old at this stage. 1, 2, 1, 2. 2 by 1. 2 by 1, 2, plus 3 by 2, 6. 2 and 6, 8. Yep. 4 by 1, 4. 5 by 2, 10. 4 and 10, 14. Fantastic. Last one. Cool, I've got equation 1 and equation 2. Fantastic, alright. They don't match. These don't match. Crap. 3 into 5, that doesn't go so nice. Maybe there's a better option. 4 into 6, I mean, they don't go so nice either. Well, here we've got an option to do multiple little fiddles. I am going to deliberately pick the x's to kill off. You could pick the y's to kill off, but I'm just going to pick the x's. So I'm going to take equation 1 and times it by 5, and take equation 2 and multiply that by 3, so that I end up with 15x for each of them. Okay, well, let's write that out. Equation 1 times 5 gives me 15x, gives me 20y, gives me, what's that, 90? 90. Cool. Equation 2 times 3, 15x again, good. 3 by that, 18y. 3 by that is, what's that, 2 is 3 is 6, 84. Beautiful. Cool. Fantastic, we've got 15x on both. We'll call this equation 1 star, equation 2 star. Cool. Everything in equation 1 star is bigger, so we've got equation 1 star minus equation 2 star. 15x minus 15x, dead. 20y minus 18y gives me 2y. 90 minus 84, 6. Divide by 3, divide by 2, gives me 3. Bang, 1 down, 1 to go, sub it in. Could pick either of them. I'm going to pick the first one for no particular reason. Numbers are a little bit smaller, but it's not the worst thing in the world. So we've got 3 lots of x plus 4 lots of y, which is 3, equals 18. 3 plus 12 is 18. 3x equals 6. Divide by 3 gives me 2. Cool. Y is at 3. X's are 2's. 3 by 2, 6. 4 by 3, 12. 6 and 12, 18. Yep. 5 and 2, 10. 6 and 3, 18. 10 and 18, 28. Fantastic. We're happy. Beautiful. So that's a quick run. This is for J and K. I forget which way around they are. I forget if it's elimination and substitution or substitution and elimination. Doesn't really matter. You're still doing both of them anyway. L is all about worded questions for this, which gets a little bit fiddlier, but it's still the same basic thinking. But definitely email me when you get stuck on that, or if you get stuck on that, I should say, or for anything else for that matter. And that's that. Yes, done, good, beautiful. That's it. You can get fractional answers for these things later, but for now you'll get mostly integers just to make your life a bit easier. Cool, have fun, see you later.